Learn how to build powerful recommendation systems that suggest products to customers based on their behavior and preferences. Recommender systems connect users with products they're likely to purchase, creating personalized shopping experiences that increase sales and customer satisfaction. Let's understand what recommender systems are and why they're essential for e-commerce. A recommender system analyzes user behavior and preferences to predict which products they'll be interested in and makes personalized suggestions. These systems use historical data like past purchases, product clicks, ratings, and browsing patterns to learn what customers want. The system takes user data as input, processes it through recommendation algorithms, and outputs a ranked list of suggested products. There are three main types of recommendation approaches, each with different strengths. Collaborative filtering finds users similar to you and recommends items they liked. If users A and B bought similar items and A bought X, recommend X to B. This matrix shows user-item interactions where green connections represent purchases or high ratings, helping identify patterns between similar users. Content-based filtering recommends items similar to what you've liked before, using product features like category, brand, price, and attributes. Hybrid systems combine collaborative and content-based methods to overcome limitations of each approach and provide more accurate recommendations. Let's build a basic collaborative filtering system, starting with the data structure. We represent our data as a user item matrix R, where M is the number of users, and N is the number of items. Each row represents a user, each column represents a product, and values are ratings from 1 to 5, with 0 meaning the user hasn't rated that item yet. To find similar users, we calculate similarity scores using mathematical formulas. Cosine similarity measures the angle between two user vectors. Higher values mean more similar preferences between users. When the angle theta between user vectors is small, cosine similarity is high, meaning these users have similar tastes. Here's a calculation example. If user A rated items 5 and 3, and user B rated them 4 and 0, the cosine similarity is 0.86, showing high similarity. Once we find similar users, we predict ratings for items the target user hasn't seen. This formula predicts user U's rating for item I using weighted average of similar users, ratings, adjusted for each user's average rating. We find the target user's similar neighbors, weight their ratings by similarity scores shown on edges, and combine them to predict the rating. Let's look at the key code components to build this system in Python. First, import NumPy for matrix operations, pandas for data handling, and sqlearn for similarity calculations and machine learning tools. Load your e-commerce data with columns for user ID, item ID, rating or purchase indicator, and timestamp for temporal analysis. Transform your data into a user item matrix using pandas pivot table with users as rows and items as columns. Compute cosine similarity between all user pairs to create a similarity matrix showing how alike each user is to every other user. For recommendations, find the top k most similar users to your target user, typically k equals 5 to 20, depending on your dataset size. Apply the prediction formula using similar users, ratings weighted by their similarity scores, to estimate ratings for unseen items. Finally, rank all unrated items by predicted rating, and return the top n items, usually between 5 and 10, as your recommendations. The cold start problem occurs when new users or items have no historical data. New users have no purchase history, making it impossible to find similar users or predict preferences accurately. For new users, recommend the most popular or trending items overall as a safe default until they build up interaction history. During onboarding, ask new users about their preferences, favorite categories, or brands to quickly build an initial profile. For new items, use content-based features like category, price range, and attributes to match them with users who like similar products. We need metrics to measure how well our recommender system performs. Root mean square error measures prediction accuracy by calculating the square root of average squared differences between actual and predicted ratings. Precision at k measures what fraction of your top k recommendations are actually relevant items the user would like or purchase. Recall at k measures what fraction of all relevant items you successfully captured in your top k recommendations. Let's recap the key concepts for building e-commerce recommender systems. Recommender systems analyze past user behavior to predict future preferences and make personalized product suggestions. Collaborative filtering works by finding users with similar taste and recommending items that those similar users liked. We measure similarity mathematically using cosine similarity between user rating vectors in the user item matrix. To predict unknown ratings, take a weighted average of similar users, ratings, with weights based on similarity scores. Address the cold start problem for new users by showing popular items, and for new items by using their content features. Measure system performance using metrics like RMSE for rating accuracy and precision and recall for recommendation quality.